Welcome to Module 5, Lecture 3. In this lecture, we will extend our discussion to using learning curves to improve project cost estimates. The goal of this lecture is to apply the concepts of cost estimation and learning curves to a real-world project scenario. The reading assignment is Larson Chapter 5 Appendix 5.1 page 171. The learning curve is a concept that describes how the time required to complete a task decreases as a worker gains experience. The improvement rate can be quantified, typically as a percentage. The learning curve effect can be represented by the formula, where Y is the time required to produce unit X, A is the time required to produce the first unit, X is the unit number, and B is the learning curve exponent. In order to use the equations, let's look at a specific example. Space Tech Innovations has a contract to produce 6 autonomous drones for Global Surveillance Solutions, GSS, a company that offers worldwide aerial surveillance services. These drones will enable GSS to monitor and manage large-scale events and operations remotely, ensuring safety and efficiency. Space Tech Innovations will develop and produce the 6 drones. Here are the cost and labor estimates for the project. R&D costs, $800,000. Material costs, $450,000. Labor costs, first drone will require 80,000 labor hours. Learning curve, a 90% improvement curve is expected. R&D costs, $800,000. Labor rate, $35 per hour. Desired profit, 20% of total costs. To determine the total labor hours needed to produce all 6 drones, we use the learning curve formula. The learning curve indicates that as production continues, the time required to produce each additional unit decreases by a certain percentage. First, start by calculating the time required to produce the first drone, which is given as 80,000 hours. Second, the learning curve percentage is 90%, meaning each subsequent unit requires 90% of the time taken for the previous unit. Third, we calculate the learning curve exponent B. Fourth, we will calculate the labor hours for each of the 6 drones and sum them up to get the total labor hours. Fifth, we will determine the total labor cost. Finally, we will calculate the total cost by summing up all the costs associated with the project, including R&D costs, material costs, and labor costs. This slide shows how we calculate the learning curve exponent given that it equals 80,000 hours and the learning curve is 90%. Here we get B equal to minus 0.152. Here we calculate the labor hours for each of the 6 units by using the formula. So here the labor hours for the first unit is 80,000 hours, the second unit is 72,000 hours, and so on. Notice the time gets shorter for each consecutive unit. Finally, we sum to get the total labor hours. Here we calculate the total labor costs by multiplying the total labor hours by the labor cost per hour. The total labor cost is $14,282,220. Here we calculate the total costs by adding together the R&D cost, the material cost, and the labor costs. Note, the R&D costs and material costs were given in the problem statement. The totals comes to $15,532,205. Here we calculate the desired profits, which are 20% of the total costs. The desired profit is calculated to be $3,106,441. Finally, we calculate the total price, which is the sum of the total costs plus the desired profit. The total price is calculated to be $18,638,646.